So let's start. Okay, I'll start again. So you're saying we look at partial fractions today. So we have this one here. If f of x is some function expressed in this form here, we have a function in the numerator and another function in the denominator, and that the degree of p of x, this function here, is less than that of this function here, and that p of x and q of x have no common factors, then f of x, this one here, can be expressed or written as a partial fraction decomposition in this form. So you can have, it can be decomposed to further with this function, the first function. We also have another function plus up to fn of x, depending on what kind of function you have in the numerator and in the denominator there. So that's what we have. And then we have the procedure for finding a partial fraction decomposition of a rational decomposition depends on the factorization of the denominator of the rational expression. So if we have this rational expression and we want to decompose this one into partial fractions, then the decomposition depends on the denominator there, which is the q of x in this case. So for us to do that, we are going to discover that there are three cases for us to do that. So we can have, let's look at the three cases or the three types. So we have when a function is in this form, f of x, which is a linear case. When you have f of x in the numerator and you have something like that in the denominator, then this form here can be decomposed as a over this one, x minus 1 plus b over x plus b plus c over x plus c there. Then case 2, we have repeating linear factors. So if you have something like this, x plus a, x plus b to the power 3, then this is going to be, can be written as a over this one, b over this one, then c over this one, then finally d over this one. So it's repeating. Then when we have the denominator in quadratic form, we have f of x over this one, the quadratic expression. And if this one cannot be factorized any further, then you are going to have something like this, ax plus b over x squared plus bx plus c, then plus c over this linear term there.
Excuse me, sir.
Yes.
I think you're too fast.
Too fast. Okay, I'll be slow.
Yes,
we are going to look at
the networks.
All right, so we are going to understand this. So I just want us to go through this quick. So we are going to understand when we look at examples, we are going to see how to use this, these cases to express a given function into its partial fractions. So these are the cases we have to look at. So there's case 1, case 2, and case 3. So let's look at an example. Yeah. Is that example? So we have some examples here that I want us to look at. So we're going to see how to express this fraction into partial fractions here. So you have an example here. Resolve the fraction, this fraction here, 11 minus 3x over x squared plus 2x minus 3 into partial fractions. Then you have our second example, third example, fourth example, and our fifth example. So we're going to look at the first example, the second example, and maybe the third example if you're going to have time then. we'll see where we're going to end. Okay, so let us look at the first one. So we have 11 minus 3x over x squared plus 2x. Then you have minus 3. So that is our first example. So here we are going to look at the denominator. Okay, we're going to see that is a quadratic function. So we see if this is factorizable, we are going to factorize. So let us try to factorize this one, the denominator. So x squared plus 2x minus 3 will give us, so you can have something like this, x squared. When you look at this, the negative 3 there, you can have minus x plus 3x, then minus 3, which is equal to, so you have x, then x minus 1. Here you can have a plus 3. Then you have x minus 1. So this one will be equal to x minus 1, then the x plus 3. So that is factorizable. This one here can be rewritten as 11 minus 3x over x minus 1 over x plus 3. So we see the denominator, this corresponds to the first case there. Yes.
How did you find the negative x?
This negative x. Oh, I thought we know how to factorize quadratic. Okay, so here we are factorizing here. So you look at, so we have, when you have something like this, x squared plus bx plus c being equal to 0. So how do you factorize this one? So you look at this product AC, then you find factors of x, AC, such that when you multiply, you're getting your AC, and then when you add, you are getting this number here, B. So this is what you've done here. So here you see a 1 here, which is your A there. And then you see your C is negative 3. So you have negative 3 there. So the factors of negative 3, you have plus minus 1, plus minus 3 there. So I see, okay, when I say negative 1 and plus 3, because negative 1 and plus 3, I'm going to get a 2, which is here. And then negative 1 times positive 3, I'll get a negative 3. So I can use this one. So it's simply factorization. I thought you're supposed to know this, how to factorize quadratic equations here.
Excuse me, sir.
Mm-hmm.
What does the question require us to find? I've come a little bit late.
No.
Oh, so we are decomposing
This
this fraction here into partial fractions.
Okay, thank you.
Yes. So this is similar to our first case. So you see that this one will be equal to A over this one, your x minus 1, then plus B over x plus 3. So when you multiply both sides by this denominator here, this side you're going to get 11 minus 3x being equal to, when you multiply this denominator throughout here, you're going to have A times. So you see when you multiply here throughout this, you discover that this one and this one will go into this one, then you just remain with x plus 3. Then you have plus B. When this one is multiplied by this one, you get x plus 1 there. Okay, so for us to find our a, so we can,
Excuse me, sir.
yes.
Yeah, I'm behind here. Why are we multiplying? Yeah, one multiplication there. I'm not clear.
We are not clear.
Yes.
Okay, so what you're simply saying here is it's like this, huh? So let me give an example. So I have an expression, for example, like 1 over 2x being equal to, say, 4. So what will happen is I want to remain with the x here. So in this case, my x, I'm seeing my x as this expression here. So I'm going to multiply, when I multiply this side by 2, I also multiply this side by 2. So I'm balancing here. So that this one and this one will go, you remain with your x. Then here you are going to remain with 8. So you are solving for x. So this is the similar case that we have here. Or if you don't want to do that, you can say this one here. So 11 minus 3x over x minus 1, x plus 3. So this one you're going to get here. You find the common denominator, which is x minus 1, x plus 3. Then this one there, you're going to multiply by that one. You're going to have a, then x plus 3, then you have plus b. Then this one into there, you remain with this one, then you have x minus 1 there. So when you compare both sides, the left-hand side and the right-hand side of the equation, you see that the denominator equals to the denominator, and this one, the numerator, should equal this one. So that's what we mean there. So that's why we have 11 minus 3x, this one being equal to this one, a times x plus 3 plus b, x plus 1 there.
Excuse me, sir.
Mhm.
Why
Do
does
the
x plus 1?
Huh?
do the letters A represent 11 and 8 and negative 3?
Which,
I'm saying that do the letters A and B?
excuse me, do the letters, so remember where you're coming from here. So here we are applying our first case. Remember, when we thought of 3 cases here. So we had the 3 cases. Let me find that paper here. Okay, so here. So you're looking at partial fractions decomposition here. So these are the cases that we have when we are decomposing. I tried to explain here when we are decomposing a fraction into its partial fractions here. So we have the first case here, which is a linear case, when you have a linear term in the denominator. So you have something like this. That's how you decompose it. So when we did this, we saw that, okay, this is similar to our first case. Then we say 11 minus 3x is equal to a, then x plus 3, then we are here. So just make sure you get up to here.
Thank you, sir. Okay.
Yes. Okay. So here, what are we going to do? So you see, here you can say you let your x here being equal to -3 there. Then you're going to have that this is 11 minus 3, then by -3 being equal to a, then your x is -3 plus 3 plus your b there, your x is -3 minus 1 there. Then you have 11. So this one times this one, you're getting plus 9 being equal to, this one is a 0, minus 3 plus 3 is 0, you get a 0 here. Then here, you have minus 4b. So you have that minus 4b here is equal to 20. Then you divide by an egg 4. Then your b will be equal to -5 there. When you let x equal to -1 here, you're going to see that here you're going to get a 0 and b will disappear. So if you let x equal to 1, here you're going to have 11 minus 3 times 1 is equal to a. You have your x there, 1 plus 3. Then you have plus b. You have your 1 minus 1 there. And then you're going to have 11 minus 3 this side being equal to 4a. So you have your 4a being equal to 8. So you have that your a is equal to 2. Okay, so from here, since you found your a and your b, so you can get back there and say, okay, so this one, 11 minus 3x over this one can also be written as in its partial fractions. So you have the first fraction as 2 over x minus 1. Then you have plus your b, which is -5 over x plus 3. So which is the same as x minus 2 minus 5 over x plus 3. So that's how you decompose that one into partial fractions.
Excuse me.
Yes, I've got a question.
As is it not supposed to be 1 here down on A here, 2 over x minus?
Yes, that's 1 there. Here. Yeah, so let us look at our second example.
Yeah, Sam, behind how did you cancel 11 minus 3x over x minus 1 to 11x minus 3?
Where? Pierre, what's your question again? Okay, I think we lost that one. So let us look at our second example. So let us try to decompose this one here. The last one, I think.
So I've got a question on the first one, the same one. Yeah, I'm just behind where you are, where you are getting like, is here where you saying that 7 minus 3 minus again open brackets -3? Is it just we choose any number and then just plug in that where the value of x is?
Are they? No, let me just find this paper. Okay, so here, no, you don't pick any number. So what will determine the numbers you pick is what you have here. So here I've seen that there's x plus 3, right? And there's x minus 1 here. And okay, if I want to find the value of b, so I need to be careful. I need to choose the value of x here, which when I put there, at least it will make one of these 0. So here I see -3 is going to make a 0. So you pick -3. And here you see this is x minus 1. When x is 1 there, you see it's going to make the other variable 0 here. So that's how you pick the numbers. It's not that you pick any number. So you look at the terms there that you have, and that will make you eliminate one of the letters here, either A or B. So you can start with any one. It doesn't matter. Okay. Let us look at this one. So decompose this one into its partial fractions. So yeah, when you analyze this, you're going to see that this is also a linear term, which is the first case. So this one can be expressed in this form. For example, we have